Hey, how's it going, guys? My name's Daniel, aka HashLips, and welcome to the continuation of learning Solidity with me. I think so far we've done so great. Today we're going to look at an interesting concept called modifiers. What is a modifier and how does it work? Well, what I want you to do is basically go and type out the mymodifier.sol, create a file, and type this basic structure out, and we're going to get started. The first thing that we need to understand is that modifiers are there to help us facilitate functions and help to tell functions what they can do and cannot do. It's sometimes like putting a require statement inside a function, but making it reusable for other functions as well. I'll go ahead and explain. Let's say we have this basic smart contract. Let's start off with a variable. I'm going to create a number variable like so, and then I'm going to create a boolean, and I'm going to call this boolean paused. Paused is going to be false. Now, what we want to do is create a function that basically increments. So add to num, and then this is going to be a basic public function. We're going to have our brackets, and this most probably will go and update the storage data over here. So let's just make a simple function, and this function we're going to increment. See how we use this nice operator symbol to do this effectively and easy for us. This is a basic function. So let's go and deploy this and see it run. So we're going to deploy that. We're going to also have to make the mynum public just so we can see it. And we don't really need to make the paused public, but I am for this example, just so you guys can see the values. So let's redeploy that. There we go. So now we got a mynum, which is 0, paused, which is false, and add to num. Every time we click on this, we're going to be adding and incrementing our number. Okay, so we're going to increment it. Now it's 7, now it's 8, and so on. But let's say we only want this number to be incremented if the contract is not paused, if this variable is not paused. Now, how I explained this to you guys before, we can do a simple require check. So we can check and say, well, if this smart contract variable over here, if this is paused, so let's say if this one is equal to true, right? Just like so. Then we're going to pass this, right? So let's just think about it, because we need this to fail. So as long as paused is equal to false. All right. So it requires this to be false. So it says that our smart contract cannot be paused. If it is paused, if it's not equal to false, meaning that it is true, then it's going to break. And then we can say contract is paused. Okay, like so. After adding this, this is basically modifying this function in a way that it will only do this if it passes the require statement, like we learned before. So we can go and run this again, and this time we can go and add to the values, and we can see that it adds and pause is false. We have no way of setting this contract to paused, so let's go and create that function quickly. Set paused. And this is just going to be a public function. And all we're going to do is set this variable paused equal to true. How you would basically do this function in a real application is you won't just set hard-coded values like that. You would most probably pass in a state that you would like your variable to be set to, so that you can reuse functions. But anyway, for our use case, this is perfectly fine. I'm going to redeploy the contract, run this, then I'm going to increment the values, check if I can still increment, and I can. But as soon as I set this contract to paused, which I can see is true now, even if I increment, it throws an error and it reverts, and my number stays 4. Now this is very cool, but let's say I had another function which was subtract from num. So let's say this function was subtract from num, and this one, instead of incrementing, we're going to decrement. Now this is all cool and will definitely work, but we have this exact same require statement on both these things. Isn't it better for us to rather create a modifier, something where we can reuse, or something that we can reuse that executes this same kind of logic? Modifiers can contain a lot of different logics, but this is one example. In order to create a modifier, you can start off with the modifier keyword, much like a function. We then can go and give it a modifier name. So we can call this is not paused. All right. We want to check if this contract is not paused, then you can go and execute. So basically we open our curly braces and we then go and put our require statement that's in here. We cut it out and put it in the modifier. We can then go ahead and remove this one as well, because we're going to reuse this modifier. Next, what you want to do is you want to actually specify what code should run after this check has ran and passed. You do this by specifying an underscore and a closing semicolon statement. This little symbol is very hard to understand for someone, but imagine this as the rest of the code that should execute. When you add a modifier to a function, which I'll show you just now how to do, you're basically saying that it should append this logic first, and once it's done that, then only you're going to run the code again. Let's check the logic. So we're saying that this is our modifier, is not paused, and then we're saying require that the contract is equal to false, meaning that the contract should not be paused. To add a modifier, you can simply go onto the function after the public statement, and you can go and paste it there. This modifier now is going to be appended to this function, and if we also append it right here, it would work exactly the same. We can now basically go ahead and run this program again, deploying our contract and seeing its logic working. We can see that we have our number and the paused, and if we go and add to this number, we can see that our number is adding. If we subtract from this number, we can see that it's subtracting. But what happens if we set this to pause now? If we try and add to this number, you can see that the transactions fail and our number stays at 1. Even if we try and subtract from it, it doesn't work. Because behind the scenes, this modifier takes this code over there and puts it basically before the code inside this function runs. That is what a modifier does. And you can have various different modifiers. A great example of a modifier is something like this, where we only want the owner of this contract to call this certain functions. So if we said that this was an only owner, like so, so we have an only owner modifier, and then we say that this only owner needs to be the owner of this smart contract. How do we get that? Let's go and create an address variable type up here, and let's call it owner. Now the owner is going to be equal at the first on the first instantiation to nothing, and then we're going to use a constructor, which I'll get to just after this series. The constructor is going to basically run once, like I explained to you guys before, and we are going to set the owner to the global variable message.sender. Here we can say that the owner is going to be equal to an address, and we're going to specify this address as the message.sender. Remember the global variables that we talked about. Now this owner should be set, and we can make this public just to make sure that the owner is who we say it is. In this case, the owner will be the person who deployed this contract, but you can set it as whoever you want to with functions. You don't only have to set it in the constructor basically. Now that we have this logic, we can actually specify and check if this is only the owner. So we can say that if this fails, this is not the owner, right? And also we can then update our check statement to say that the message.sender is equal to the owner up here. Now, why do we have this message.sender over here? Well, think about it. If we add this modifier to our function, and you can append multiple modifiers to your functions, basically if we say that only the owner can call this, we are appending this line inside here, remember? So the message.sender is the person calling this contract and executing this function. Therefore, it's going to check if that's the owner basically. And that's all a modifier does. So now that we've updated this, we can actually now redeploy and check if our modifiers behave correctly. We can go and we can say that we want to add to our number, check on number, it's 2, it should be 3, let's add one more, 4. We can check the owner, and the owner is this address over here. This is the address, this address where we deployed the contract from. But let's go and change our address and try an increment. If we try and add, you can see that the smart contract fails and nothing gets added because these two functions can only be called by the owner and if the contract is not paused. That's how you use modifiers. On a side note, much like functions, modifiers can take in parameters. So we could say maybe we want to have a parameter bypass in here. So let's make a value and call this bool, and we're going to say this is a bypass, I don't know, like that. And then we can say that we need to bypass this. So in this modifier, we can actually say if the bypass is equal to true, okay, and only then we want to check this require statement. That means that we're going to bypass whatever logic we have set in place for our paused contract. And that's basically cool because now we can say is not paused, but we can also have the option to bypass certain modifiers. So for instance, in here we can say that yes, for the add to num, we want to bypass this function's modifier, but this one, no, we don't want to bypass it. It should be paused. Please don't write your code like this just by passing in random values in a function that's name is not paused, because this will create confusion. But anyway, this is possible to add parameters to your modifiers as well. Next, we have to look at events, a very cool subject. Go ahead and create your myEvents.sol as well as the default structure that we have in place. Create a smart contract and call it myEvents, and let's get started. Sometimes we want to know when things happen on the blockchain, and the only response we get as a front-end user of the blockchain is when a transaction actually takes place, when it's mined and actually then comes back with a receipt. But there's actually another way where we can read the data of the logs of the blockchain. Events allows us to capture a piece in space and time and tells us what exactly happened on that transaction by passing in some data that we can save on the event logs. Events are a great way for front-end users and normal users to actually see what took place on the blockchain with a particular smart contract and functions. Think of it as a message board, and whenever we do something important, we want to log it and put it onto the blockchain so that on a later time we can retrieve it, we can read from it, and it just helps to store what happened on that blockchain and with a transaction. On a later stage, we'll look at how we can interact with events from a front-end point of view, but let's see how we can actually implement it in our code. The ERC 721 contract actually makes use of events when you transfer or mint an NFT. It kicks off those transaction events, and that you can also have a look at. But you can also add your custom events to any function you would like to. To declare an event, you can go and say event, and you give it an event name. Let's just call this event name maybe created. Let's give it like that. Created NFT, like so. Then what you want to do is open your brackets and close it. This is the event structure. Now we can give it a few things that happened and data that it needs to save. So let's go ahead and define the data that we wanted to save. We want this particular event to save a unsigned integer, which would be the ID, and let's give it another unsigned integer to save, and let's say we want to save the DNA. That's what we basically wanted to save. We don't have to add these underscores because it's not a function parameter, but this is how we want the data to be displayed and saved on the logs. Now let's go and create a function, and this function is going to be very basic. It's going to say create NFT, like so. Then we're going to make it public. We are also going to open up the brackets. We are not even going to save this on the blockchain. We're literally just going to use it for logging events. So I want this to actually take in two arguments, which is the ID. And I also wanted to take another argument, which is the DNA. Now that I have these two arguments, I actually want to do stuff. So in this space, you'll usually create the NFT and save to the storage. All right. We actually want to create the NFT and save it to the storage. But after all that happened, now imagine this program was already written. We want to emit the event. Now we already defined how the create NFT event looks like. Down here, we can simply emit it. So we use the emit keyword, and then all we need to do is we need to specify what event we're going to emit. So we want to emit this create NFT. We then again open the brackets, but this time pass in the actual parameters that it needs. So the ID and the DNA. By doing this and executing this function, this event will be emitted and saved on the blockchain, on the transactions, and on the logs. And on a later stage, we can retrieve it again. I also want to note that to make it easier to follow through and search for logs on the event chain, you can sometimes add an index in front of your type definition, like so, indexed. The index keyword just means that you can basically easily look up this data based on this ID. Usually, you would kind of maybe want to save an address. So you would maybe want to have a type of address, make this indexed, and give it the variable of the user or something. When you do that, you can see that our emitter does not comply now with our new structure. So let's update that. It will need an address in this field. We know that we can get the address from the message.sender, like so. So we have a message.sender, which is the address, we have an ID, and we have a DNA. And by doing this, this function will emit an event. So now if we try and deploy this contract and we point it to some kind of JavaScript virtual blockchain, let's just make sure that we deploy this new contract and we can see that it's deployed successfully. You can see that here we have our create NFT function. The create NFT function is now going to take an ID and some DNA, and when we transact, this will basically be calling it on the blockchain and then emitting this event, saving it in the log. That is basically what you want. And on a later stage, what you can do is then go and traverse through the blockchain, through the logs, and go and see these transactions and actually use it in the front. Maybe you want some history. Maybe you want to know if a certain event takes place to inform the users on the front. These are very cool events to listen to when you have a front-end application. Let's move on. Let's take a closer look at constructor functions. Go and create yourself the myconstructor.sol file. Go and place in it the license, a pragma line to specify to the compiler what Solidity version we want to run, and create an empty constructor contract. We're going to call this contract myConstructor, and inside we're going to define a string. We're going to call this string name, but we first want to define it as public, then give it a name, and we're not going to assign any value to this name. We're going to leave it up to the constructor to do it for us. A constructor function is something that can be called once and only once, and is called automatically when you deploy a smart contract. You don't always need a constructor, but behind the scenes it does call it. When you define a constructor function, it's defined like this. Put the constructor keyword and then just put brackets and curly braces. A constructor function doesn't need a name, and there also can't be a duplicate of the constructor function in a given smart contract. A contract can only have one constructor function. Then, how can we use this constructor function to update our name? A constructor function is there to basically construct, initialize values that you want to have on the start of your smart contract. This function will never be called afterwards again. So on the start of our smart contract, we want to maybe set our name equal to HashLips. Once we do this, we can actually go and save this and go to the deploy section, then going to deploy my constructor. And once we've done that, we can go down here and click on the name variable, and we can see that indeed it was set to HashLips. Sometimes you would like the constructor function on your deployment of your smart contract to actually take in parameters. Keep in mind, when your constructor has parameters, you would need to provide the verification on Etherscan or Polygon scan with that ABI, not the ABI, the bytecode of that constructor function's values. I'll show you how to get there just now. Let's go and remove all our deployments, and let's change this constructor function to take in a string, which is going to have to be of type memory, and we are going to make this the name, the initial name that we want to set. We're going to replace the hard-coded HashLips value and make it so that it takes the name field. Now that we have the constructor set up to actually take a parameter, on the deploy section, you can see that there's an extra field here on the deploy section. This expects a name to be given. If no name is given, it will be an empty string and the name will just be empty. It will default to its original value. But what we need to do is actually specify something. So I'm going to say Daniel has to be my name now. And when we deploy this contract, we get a deployment instance. And when we click on name, you can see that the constructor has initialized this variable to name. You can put as many variable declarations down here that changes the variables up here. You can also call functions, make sure your contract is set up correctly. And yeah, that is basically constructors. Another thing to note is if you work with contracts that inherit from other contracts, you have to call the underlying constructor of that smart contract. Let's take an example, and let's say we had another contract. We're just going to declare it in here. So we're going to say contract, and we're going to call this my second. Okay, so we're going to say this is my second contract, and my second contract is going to be of type my contract. So it's going to inherit from it. How do we do inheritance? We use the is keyword, we put the contract we want to inherit from, and then we open the curly braces. You will see that now there is a little warning sign. and it says should be marked as abstract. This usually implies that we are not fully implementing all the features that's needed to be implemented from the MyConstructor smart contract, aka its constructor. We need to call this constructor for it to be used successfully. Let's see how we can do that. In my second smart contract, we can basically go and define our own constructor function, and then we can simply open and close the curly braces. But now you might ask, how do we call the underlying function? How do we call this constructor? Because we need to call it in order for this to work successfully, in order for this smart contract also to have access to the name and everything working perfectly. Well, that is easy. All you need to do, and how you can specify that, is you have your original constructor in here, and it ends here with the curly braces. We'll start with the beginning of the curly braces, but let's say we have our smart contract over there. We can now append it in this space. We can say that we have a constructor, but on the MyConstructor, we also want to call this. And what do? We pass in a name. So now we can pass in the name to this constructor. But where is this name going to come from? We actually have to define it in here. So we need to say this is now going to be taking a string, which is going to be of type memory, and this is going to be our name. This variable we pass down to the next contract basically, so that it can actually instantiate its own constructor successfully. And we don't have to actually put anything into our constructor fields. We can leave this empty. And when we deploy this smart contract, it will actually work. Let's go ahead and select our second smart contract and deploy it. You can see that our smart contract over here has a string name, and we can also enter it. When we do add something like Daniel and we say transact, we can see that on our smart contract instance down here now, this is the second smart contract and this is the first one. The second one also has access to the underlying variables that's sitting in the MyConstructor function. All right, so basically that is how it works, the inheritance and how you call the underlying constructors of other smart contracts. And when you do inheritance, you need to call them, otherwise it's going to have to mark as be abstract so that it ignores it. But you never want to really ignore things if it really needs to be in the constructor. That's it for constructors. Let's move on. We are now going to look at inheritance. So go ahead and create your inheritance file, myinheritance.sol, and complete this base structure. What I also want you to do is actually create 3 more contracts. So we're going to create 3 more down here. We're going to refer to them as A, B, and then C. I'm going to try and explain to you inheritance and how it works. Keep in mind that contracts like these don't always exist in the same file for best practices. You usually import them from another files at the top before and or after your Solidity pragma line. So before your contract starts, you have your import statements, and then you go ahead and you actually execute the rest. But for this tutorial, we actually want to keep all the contracts here in this file so I can show you exactly how they behave. What is inheritance? Inheritance means that when a smart contract inherits from another one, it basically gets all the attributes and functions, methods, everything that it has that is publicly or internally available, it will hand over to the next smart contract and say, this is yours to use, you can use it as it's your own. Let me show you how it works by first declaring a string. Let's call this string name, and we are going to make it public. We don't need to make it public for other smart contracts to read it. This can also be internal. But I'm going to make everything public just for simplicity's sake. I'm going to define this name as HashLips, like so. then what I'm going to do is I'm actually going to inherit from A in contract B. How you do inheritance is you use the is keyword. You can then go and inherit from my inheritance A, and B should actually have access to name. Let's prove this by writing a simple function that returns this name to us. So let's make this internal so that we know that we're not going to have access to that from the outside world, but B is going to expose name to us. So we're going to say function get name, like so. Get name is going to be a simple public function, and all it's going to do, it's going to return the name for us. If we return in Solidity, we need to remember to actually type in the returns statement to make sure that this function does return. And the thing that is going to be returning is a string. And if we're returning strings, arrays, and structs, we need to put in memory. And lastly, we want to add the view so that we know this is going to be a viewable function. Now, what we want to do is go to our deploy section, make sure that we have my inheritance B selected, and deploy it. What we'll see is we have this function that's exposed, and when we say get name, we get HashLips, and that is very cool. Even though HashLips, the name variable, doesn't exist inside the smart contract here that we can see, behind the scenes, this variable is exposed and is available in this smart contract because we're inheriting from A. That's basically how it works. Another example of how this works is if C were to inherit from B, we will actually automatically get this getName function. Let's go and try that out. If we put is my inheritance B over here, we are now inheriting from B. Let's go and save this, close our deployment sections, and only deploy C. We are deploying this contract which has nothing inside of it. But if we deploy it, we can see that we do have access to the get name, and it truncates and it makes sure that all the features and functions exist. We do not only have to inherit from one contract, we can inherit from as many as we want to. So technically, we can also inherit from A. So we can say we want to inherit from A. This will cause a problem though, because B is using A, and we probably would need to rearrange the order. But that being said, you need to make sure that the order stays then correctly, knowing which ones inherit from which. But it won't make sense inheriting from A and B at this point, because B already has everything A has. So we don't need to do two inheritance here. But sometimes you would like to inherit from other smart contracts, and you usually see it with the ERC 721 contract, where we inherit from it and we inherit from the access control contract, which is ownable. The thing I want you to have a look at when inheriting from other smart contracts is sometimes we need to overwrite a function. What if I wanted a different implementation of the get name in my inheritance C, and we are inheriting this from B? We need to make sure that we are able to do so. How can we achieve this? Well, first, if you want to overwrite a function, then basically it needs to be marked as virtual. The virtual field will basically indicate to us that we will be able to overwrite this. So just make sure that's virtual. And once we have this and we go and implement this in our myInheritance C contract, this means that we can have the same name and we can go and override it. And all we need to say is that we want to override this function. This will still work, and now we can return whatever we want. Maybe even we wanted to return something else. Maybe we have our own name that we want to return. Maybe I want to always return Daniel. It doesn't matter. But as long as you understand that when we deploy now the instance C, we're going to deploy that and we're going to deploy B. As long as you understand that B's implementation of getName will get the name from HashLips, and C will also have the getName, but because we override its implementation from B, it will get Daniel because we explicitly say that's what it needs to do. This is a way of overriding functions, and you will see this happen a lot in the ERC 721 space, especially when you want to get the token URI. Sometimes the token URI function is overridden to kind of promote different scenarios. Sometimes you want to overwrite it to hide the reveal of an NFT or something like that. So you take the underlying function that it inherits from and you adapt it to your own needs by overwriting it. That's all you need to understand. The virtual tag just allows this to be overridden, and then once you have it, you go and put override and you go and overwrite this function. That is if you want to overwrite the exact same function name. Otherwise, you can just specify a different function name, obviously. But that being said, I think this is all for this video. I hope to see you guys in the next video, and I am really excited to keep on teaching you Solidity.